Okay, here we have a ball bouncing off the floor. The incoming velocity is 10 meters per second and it makes an angle of 30 degrees with the floor. And when it rebounds, it makes a bigger angle of 40 degrees, but it's lost a little bit of energy, so it's coming off at 8 meters per second. And the question is, what is the impulse responsible for this change in direction of the ball, change in momentum of the ball? So first of all, impulse we can calculate by using force times time, but we can also calculate it because it's equivalent to a change in momentum. So impulse is change in momentum is what we want to use. And change in anything in physics is always P final minus P initial. It's always final minus initial when you're doing a change. So we're going to do this with components. So let's start by figuring out our initial and final momenta. So I've drawn these arrows on the right-hand side here to represent our momentum vectors. So initially, we've got a 0.5 kilogram ball moving at 10 meters per second. So P initial, I just go mass times velocity initial, and I end up getting 0.5 kilograms times 10 meters per second. And that gives me an initial momentum of 5 kilogram meters per second. So this initial momentum right here, P initial, is 5 kilogram meters per second. Now P final over here will be 8 times 0.5. So P final, same mass, and I just use V2 in this case, or V final. And 0.5 times 8 is 4 kilogram meters per second. Okay, now we have some angles. The angle down here is 30 degrees. And the angle right here is 40 degrees. So we're going to do this with components. Let's start with our x direction. The x component of our impulse will be P final in the x minus P initial in the x. Notice it's the same equation we used above, we're just breaking it down into x's and y's. So let's figure out our components. P initial consists of a y component that's straight down and an x component that's to the right. Now we got to watch our signs when we do the component method. So my y component will be 5 sine 30, which is P initial y will be 2.5. And if I go 5 cos 30, I'll get P initial in the x. And 5 cos 30 is 4.33. Now the initial y value is down, so I've got to make sure I put this negative in there. That matters. The x is to the right, so we're going to leave it as positive. Now let's do the same thing with our final momentum. If I go 4 cos 40, I get a P final in the x of 3.06. And that's positive because it's to the right. And I also have a y component that's straight up. And because that's opposite to the 40 degree, that will be sine. And 4 sine 40 is 2.57. So that's P final in the y. All right, we're focusing on the x's to start. So we're going to go P final x minus P initial x, but we've got to watch the signs. Fortunately, they're both positive in this case. So I go 3.06 minus 4.33, final minus initial, and I get a value of negative 1.27 kilogram meters per second. So now I know the component, the x component of my impulse. Now let's do the same thing in the y direction. Impulse in the y will be P final in the y minus P initial in the y. Now my final momentum in the y was 2.57 and it's up, so that's a positive number. And we're going to subtract my initial momentum in the y, which was down, so it's negative 2.5. So you can see why you got to watch the signs here. And when you work all that through, you end up getting a y component of 5.07. That's positive. So my y component for my impulse is positive 5.07 kilograms meters per second. Now, once we have the components with the component method, the last step's always the same. We put our components together tip to tail, and then we find the overall resultant, or the hypotenuse. So I'll do that in pink so we can see it clearly on the left. The x component of my final impulse is 1.27 to the left because it's negative, so it looks like this. So that's Ix. And then at the tip of this one, I'm going to add 5.07, which is straight up. So 5.07 is my y component. And my overall answer will just be this hypotenuse right here, like that. Now I haven't necessarily drawn it to scale. This 1.27 should be a little bit shorter. Now to find the hypotenuse, as usual, we go a squared plus b squared equals c squared, because anytime you're dealing with components, you've got a right triangle, so you're allowed to use Pythagoras. So if I do that with Pythagoras, I'll get 5.23 as my hypotenuse. And then to find the angle, I simply do tan theta. So to find the angle, maybe I'll do it in a different color again so we can see it. I might go tan theta is opposite over adjacent. And when I go inverse tan, I get an angle of 76 degrees. And that would be north of west. So my overall final answer for my impulse, after I do Pythagoras, is 5.23 kilogram meters per second at 76 degrees north of west.